Okay, good evening, class. Today we're going to discuss, we're going to discuss descriptive statistics. This is actually a continuation of what we were doing last time. I don't think my screen is shared. Share. All right. So as we go along, to save on time, I'm going to share some the codes with you. So may I request you to open a new RMD file? You may name it descriptive statistics. Okay. And for some of the codes I'm going to share with you, for some, I would like you to write it on your own as also a practice. Okay. And we'd like to make use of some packages. Actually, class, okay, let me put this Control X, Control V, tidyverse. Technically, you don't need to load dplyr and ggplot2, but you need to load scales in order to, if you load tidyverse, because dplyr and ggplot2 already comes with tidyverse. So you will know that these packages are already installed and loaded if you go to packages window and then type the package itself. For example, here, tidyverse. If you see that there's a check mark there, it means that it has been loaded. Okay. It means that I have run library tidyverse or require tidyverse. Same thing with dplyr. Dplyr. Okay, when I loaded tidyverse, it automatically loaded also dplyr and also ggplot2. ggplot2. Okay. Scales does not come with tidyverse, so you will need to, okay, scale functions for visualization. For scales, you will need to install the package and then load it using library. If you recall, last time, you can actually, let me just illustrate that Control I, and just make sure first that your Pacman package, which is package management tool, has already been installed. If it's installed already, then we can, okay, I'll just copy this, Control C, Control B. Okay, so this is more on, okay, and then I'll just Control F, Control for Mac, it's Command F, I think. And then I'll just type library, and then I'll replace all with nothing. Let me see, all. Okay, so okay, so it removed the, then maybe also Control F here, and then I'm going to remove also just this, so that I don't have to keep on deleting it all. Oops, sorry. Why 170? Control Z. Oh no. Oh no. It means that it deleted. Okay. Wait, class. Yeah, my bad. So it removed the others. Other 170. I'd rather, class, I'm sorry. I'd like to close this, and I will not save it. Close this. I'm going to close my R, okay? Because I'm afraid that there are. I'm wondering why there are 170. Okay, I think the other parentheses were, yeah. So I'm going to close this. Close without saving. Okay, don't save. Okay, sorry about that. And then I'm going to open. Okay, sorry about that. Okay, so desktop, and it's in my COB 516. Now, this is the advantage of of having your file inside an R project. I did not save it, so it's under this one. Okay, I'll open the project here. Okay, all right. While it's loading class, again, the objective for tonight is to go through some of the descriptive stats and some data visualization functions in R, which are needed for your paper. And normally, before you start with your statistical analysis, okay, files, so I'll delete this. Okay, I actually don't need this. And then I'll open this one here, descriptive statistics there. Okay. All right. I won't use anymore the Pacman. Okay. We discussed that last time actually. Or did we, class? Did we discuss Pacman? May I have your confirmation, please? Did we discuss the function Pacman? Did we, class? Let me check that. Here. Okay, here. You learned how to. I don't think so. Okay. So anyway, I'll just discuss it. Yeah, okay, good. Thank you. Thank you, Dom. All right. Okay, so sige, discuss ko ngayon, no, para aware kayo. Now, Pacman, let's first load it. Let's first install it. So you go to packages. Either you type install that packages, or for somebody lazy like me, where I don't want to type, I just want to go to packages and then install, or go to tools and then install packages. Anyway, any which way you want. So I'll go here. It's the same dialog box. I'm going to type here Pacman. Okay. So once you type Pacman, install. Okay, I won't do it anymore because I already have it. Okay, and if you check your packages class, Pacman, you'll find it loaded. Okay. So you'll find it installed, but we will not load it. Pacman has some pretty powerful packages that you can use in managing packages. So for example, you're going to load these packages. Okay, the advantage of Pacman, Control Alt I, okay, the shortcut for creating a new code chunk is this one. Then I can identify Pacman double colon and then P underscore load. So there's a function in Pacman called package load. Okay, in fact, it says here, okay, this function is a wrapper for library and require. So it means that it can install that packages and library or require at the same time. Okay, whereas last time what we did was first install that packages and then library or require. for payload, it both installs the package and also loads it automatically. So let me let me do this. Okay, I don't. In fact, you don't have to load Pacman. Okay, just make sure it's already installed. So let me illustrate this by going to, let's say, scales. Okay, this is scales, and what I'm going to do is, okay, here I can remove this. You can remove packages. For example, scales. I'm going to remove this package, and you can see that. Okay, did it run already? Let me clean this first. Scales, remove. Are you sure you want to permanently uninstall? Okay. Okay, yes. So I installed it, and the function, it's similar to here. Remove that packages scales. Okay. So I removed it. Now I'm going to, okay, it's no longer here. Can I install it and load it at the same time? We'll see. So we're going to use the p underscore load function. Okay, and then we do dplyr, okay, ggplot2, scales, and tidyverse. As I said, class, when you load tidyverse, okay, you don't actually need to load dplyr and ggplot2. So this is not a good way to load packages. So let me just delete this and just use tidyverse. Okay, because anyway, when you load tidyverse, it will load the other packages that are dependent, uh, that where tidyverse is dependent on. Okay, so note that I don't have scales here. So I'm going to use pacman, and pacman is not yet loaded, but it's already installed. So no problem, even if it's not loaded, R can access the payload, because you identified that this payload is coming from pacman. So I'll run this. Okay, installing package. So it's installing. Tidyverse successfully unpacked and loaded. So I'm waiting for scales. Okay, there we go, class. There's some comments here. Okay, let me just delete the comments and check, class. Scales. Okay, update. And wait. Okay, this is different. Wait, sorry. I should have scales. Here I should have this one. Refresh. Okay, there you go, class. Scales was loaded, installed, and loaded at the same time. Okay, so there's a check there. So that's what the Pacman, uh, from the Pacman package, okay, package management, you have package slash underscore load. So this will both install and load at the same time. Okay, so let me pause for a while and allow you to catch up. And if you have done so, kindly please chat yes. You're done, class. If you were able to load, thank you. Thank you, Michael. Let's wait for your classmates. Okay, waiting for the others, class. I'll have to open. Okay, good. Right, good. Thank you. Now, what I'm going to do is I'm going to share with you some of the codes here, some of the text. So, okay, what's happening here? I opened a new document because the problem with sharing some text in Zoom is that it's so limiting. You can only share some limited amount of text. So uh, I opened our Google Sheet. Okay, I'll write here January 31 text. Okay. I will share here some of the text and codes so that we're not restricted with the lines. Okay. So let me first start with discussing what we're going to do tonight. First is, of course, introduction to descriptive statistics. Okay, introduction to descriptive statistics. And what's really the purpose of descriptive statistics? Okay, you have your data. You have to summarize your data. Okay, you have to encapsulate your data in certain metrics. For example, you're studying sales of a particular item. You're comparing the sales of, uh, uh, and you'd like to see how promotions, how promotion activities impacted the sales. So perhaps what you can do is to compare the average sales of each of the product before and after the sales, before and after the promotions, the intervention. So that way you are actually summarizing your data. Okay, you summarize your data, and then you plot your data to see if there's skewness. Okay, is the data skewed to the right, which means that there's the preponderance of more observations on the right side of your scale. Okay, and then you measure, for example, as I mentioned a while ago, yung mean or central tendency, and then variability. You measure standard deviation or variation. Okay, so we're going to, in order to study this, we're going to once again simulate. I was trying to look for data sets, okay, but sometimes they're so restrictive. So I decided we'll just use a simulated data set. That way we can choose our fields. And also although I don't expect you to really master simulating data, anyway, your cases you'll not be simulating data. For your cases, you will be getting real world data. But just to enhance our knowledge in R, just like last meeting, we're going to simulate data and view its structure, summarize and then maybe take a look at the head and the tail. The first six observations and the last six observation. Then we take a look at the distribution of the data. We look at it from categorical variables. We look at frequency tables, bar plots, and numerical variables. So we look at histograms, density plots, box plots. And then for distribution also, we check for the normality of the data. It's important for the data to be normally distributed. However, of course, in reality, not many are normal distributed. So in the course of this subject, we'll address that and see what will happen if you're, for example, having a test, doing some statistical test, and your data is not normally distributed. So what statistical test should you be doing? Okay, so this is very important. And then, as I said, measures of central tendency. Some examples are the mean, the median, and the mode. Okay, and the mode for the categorical, mean, median, mode for numerical, and mode for categorical, because the mean and the median actually do not exist for categorical variables. Okay, then also measures of variability like the range, which is just the difference between your maximum value and your minimum value. That's the range. IQR, interquartile range, which is the difference between your quartile 3 and your quartile 1. The variance, which is the sum of the deviations, square deviations of your data, then standard deviation, and also mean absolute deviation. So these are examples of measures of variability. And then at the end, let's discuss the findings in our simulated data. Okay. Okay. All right. So I'll first, okay, I'll share this. I'll share it in the, and I think the good thing about sharing it in the, in Google is that it's automatically saved. Okay. Okay. So kindly copy that to your R Markdown for the outline of your notes. Okay. So I think this is a good idea. It just occurred to me a while ago. Why do I keep on copying and pasting the notes that I want to share with you in Zoom? although the Zoom the text will be saved, but I will have to edit it and remove those that are comments coming from your end. So in this instance, okay, all the codes that I share with you is here, and there's no limit. That's the good thing about it. So kindly make sure that your Google Drive is open, and then as I share with you, please. I don't think I don't see anybody here inside. Okay, so I suggest that you open. Okay, let me share this with you. Control C. Okay. Okay. Angel, are you still having a problem with seeing the screen?
Yes, sir. It's just black on my end. I
Oh,
don't know
really?
if it's my screen.
Oh. Um,
Okay, sir. I'll just
unfortunately,
try to rejoin through
sige.
another
Oo.
device.
Yeah, sige. Okay.
Thank you.
I'll deliberately go slower so that you can.
Thank you so much, sir.
Hey,
Okay,
sir. I
sige.
think I'm also facing
Ganun din?
the parang
Same
Ah,
thing?
I think the screen also froze on my end po. Yung
Ah,
i-screen share niyo ngayon.
sige. Why don't you exit for a while and then rejoin us? Okay. So we'll go slow, okay, so that you can immediately catch up. Okay, may I have your feedback, class, if you were able to copy this? So do you agree with me that this is a better idea? That the notes will be in a Google Docs instead of just sharing it in Canvas? Oh, wait. Am I, is my screen shared, class?
I think I'm still seeing black screen, sir, right
Wait,
now.
oh, wait. How about this? So
Ay,
it was on my
kita na
end, right?
kita na po ngayon, sir,
So kanina
yung
ako pala,
Google
kasi
Docs.
ba't ba ako nag-post? Yan, nag-post ako eh. Okay, naku, sorry ah. Si Angel lumabas pa. Pero yung iba, nakikita nyo ba?
Ngayon lang po.
Ngayon lang. Okay. So, okay. Sabihan nyo ako, klase, pag, hindi nyo nakikita. No? So, let me go back to my,
Hindi ko
ito, nakita nyo ba yung Pacman? Itong ginawa
hindi
ko,
ko
class?
open yung Google Docs.
Sorry?
Yung Google Docs po. Need ng request.
Okay, sige.
Yes, sir. We need an
Ah,
access po.
okay. Need ng pero na-share ko na to dati ah. Wait. Share. Share. Restricted. Bakit restricted? De La Salle University. And kaya pala hindi ka makapasok. And editor. I'll make you editors. There you go. Okay, yan. Okay, good. All right. So let's continue, class. Okay. All right. So just like last time, class, what we're going to do is we're going to simulate the data. What will be the variables? Customer ID, age, purchase amount. Let's make this PHP, Philippine peso, spent per transaction. Then we have, I changed this. No? I made it into, what did I made this into 5. Okay, later on, I'm going to see. So I made this 5. And then payment method, either credit card, cash, or digital wallet. And then customer satisfaction rating from 1, low, to 5, high. These are these are marketing data, and also, and at least the purchase, the uh, well, this can also be used in accounting. Okay, so not I tried to be uh, how do I call it, as I tried to come up with the data that's pertinent both to marketing and accounting. Okay, so before we okay, I'll share this, class, because this is quite long, and maybe up to this point first. I have some explanatory notes there. Angel, are you here? Okay, once again, copy this, class. Copy this. Oops, wrong. Okay, so let's go through the uh, let's go to the process. Okay, just like what we did last time, we use a set that seed number so that we have the same figures. Okay, set that seed and let's just use 300. Yeah, 300. Okay, or maybe we can make it 500. Let's make it this 500. And then we're creating a table, okay, a data frame table, or it's called a table. So it's similar to a data frame, although it's more, it has some special features and call it a table. So it's both a data frame and it's a special table called table. So so we're creating this object called data, and we're creating a table. And what's inside this? Number one, the first column is customer ID. Okay, and the name is customer underscore ID. Okay, and it's equal to 1 up to n being here, the 500. So this is good because there are many portions here where we will need 500, the number of observations. So instead of writing 500 every time here, you just create an object, okay, 500, so that you can use that n in anywhere here. So customer ID is from 1 up to 500. And then space, this would be the next. This will be the next. This will be the next data variable in our object data. So the name of the variable is age, and we're generating random, normally distributed numbers. How many observations? 500. What is the mean? Okay, I'm making the mean as 45. Okay, standard deviation is 15. That means it can range from as 45 can be plus minus 1 standard deviation, etc. So standard deviation is a measure of your variability of your data. Okay. Now, did I discuss this, class? I think we discussed that last time, right? That pipe operator. Ay, hindi. Ito, yes, no? Ito, ano? Pipe operator. Okay, anyway, so if you recall, class, the shortcut of this is Control plus Shift plus N. Okay, so for Mac, it's Command Shift N. Okay, take note that this is a comment, this hashtag. So R will not read this. Okay, just the same here. All right, so take a look at this. R norm, it will generate 500 observations. The average is 45 and the standard deviation is 15. Now, the problem with this, class, with R norm is that R norm can take on negative values. So that's not appropriate for age. So what we do is to include this, okay? Again, this means and then, right? So it creates this 500 observations, the mean of which is 45, standard deviation is 15, and then, okay, P max of 18. Okay, this will now tell us that the age here can't be less than 18 because this is sales and we want this to be only adults that are buying, and P min 70. Okay, it gives us the upper bound. No ages above 70. Okay, so this gives us a more realistic data. Of course, you can choose your P max and your P min, and then we round it off. When we say round it off, because our norm will generate decimal places, okay, 0.35, 0.52. So for age, we don't want the decimal place. We only want no decimal place. Okay, so the explanation here is over here. You can refer to this. Okay, I did some explanation here for your perusal, for your reference in case you want to review it. However, class, anyway, you're not going to create data like this because what you're going to use are real world data. So you'll have to search for data from many sources, and then you're going to work on that. So this one, we're just simulating it so that we have the same data and that we have at least we learn some of the functions that come with R. So Pmax will give us the floor, Pmax. Okay, which means that all in a list, okay, all values should be greater than 18. Okay, here in a list of data, all values should be less than 70, mean. Okay, and then we round it off. No decimal places. All right, next, we create this object, purchase amount. So this is amount purchased. All right. This is not 20%. I'm sorry. Wait. 120. This should not be. So 200 over 320. Okay, just that should be 200 over 320. So X%. So just replace this first with X. I'm going to deal with that later. X%. So R gamma class, it's similar to R norm. Okay. However, R gamma, it's a function, it's a distribution, allows us to have only positive values. So if you're dealing with a number that has only positive values, then this is better. Or you can use R norm and then P max and P min just to make sure that there are no negative values. Here, we can make use of gamma, okay? And n times 0.8 means that the data will be concentrated on shape 2 and scale 120. Now, the shape 2 and scale 120, I have, so that you'll remember it, okay? I place it here. So let me just, let's just go through this quickly. When you use gamma distribution class, okay, again, class, again, we're not learning here we're actually not learning here up to how to simulate data, but just to give you a flavor of how powerful R can be. So here we're generating using gamma distribution, and gamma distributed values are always positive. So it's ideal for sales data, for purchase amounts, which cannot be negative. Okay, it will be right skewed by default since you don't have negative values. Okay, and it matches real world purchase behavior, where mostly transactions are small, but there are few that are large. Okay, so it is flexible by adjusting the shape and the scale. Okay, so we don't have to really learn about the specifics of this, but just for your reference, when I give a low shape like above it's 2, it's more skewed distribution. Higher shape, okay, less skewed, which means it's more flat, it's more picked. Okay, how about the scale? When you give a small scale, it's tighter. When for larger scale, it's wider spread. Anyway, I don't want to bother you with those details, but I just use it here, class. I use the R gamma to generate our purchase amount. Okay, then you have your comma, we're creating the next variable, product category. We learned sample last time, class, right? Sample among electronics, apparel, home goods, food, and beauty. So what I added here are food and beauty. So kindly just include here electronics, apparel, and then food and beauty. Just include that, please, in your notes. Okay, and then we use a sample. It's just like replicating a drawing out something. Okay. For the others class, I will not anymore discuss that so much. Okay. The proportion here is 35% electronics, 25% apparel, etc. And then I also came up with payment method, credit card, cash, digital payment, and here, customer satisfaction. Okay, I will not anymore discuss this because, as I said, we're not really here to learn how to simulate, but I just gave you a sampling class. So here, we're using binomial. And how many observations? And binomial is always class whole numbers, okay? Because it's used for counting. So it means here 5. So it means 1, 2, 3, 4, 5, okay? 1, 2, 3, 4, 5. So I have a customer satisfaction data from 1 up to 5. And then here, okay, product category, this is more for, we have our product category, right? This is more for arranging your product category so that when you plot it, it will be from highest to lowest. So this is more ordering it. Okay, so why don't we, I'm going to run this. Let's run this class. How do you run a code chunk? You click here, okay, run the current code chunk. So this, it will run everything here. Or you can go here and run the current chunk. Because we're here, class, make sure that your cursor is here, and then click this one. Oh, sorry. Run the current chunk, or Control-Shift-Enter. Go here, anywhere here, Control-Shift-Enter will run everything here. All right, so I'll just click this one, and you have this. Oops, what happened? What happened here? Error in mutate. Okay. All right, did you get this, class? Did you get error in mutate?
Yes, sir.
Yeah, mutate class comes from the dplyr, the tidyverse. So which means that, okay, may I check? Is my tidyverse already? Oh, my tidyverse has not been loaded because I did not run this class. I only checked the scales. So you may have to make sure that tidyverse is loaded. So I'll click this. Okay, so it's loaded and it loads with it dplyr here, dplyr. Because the function mutate class, okay, ano bang ginagawa ng mutate? What does the mutate function do? The mutate function will create, okay, will create a new object class. Okay, so you have your product category, payment method, purchase amount, and then it will mutate the purchase amount. Okay, it will change it a bit. Okay, here you're going to add outliers. Okay, we won't get into the run if thing. Okay, so let me run this. I deliberately included outliers to make the data realistic. Okay, I run this. Okay, it will now run, and we now have this data. Okay, here class, data. 500 observations of 6 variables. And clicking this is equivalent to running view. Okay, if I click this, it's the same as writing view data. Okay, so what's our, okay, what's our data? We should have the same data class. Our customer ID is from 1 up to 500. So you have the ages. Notice class, if you check, let's check class. How do you get the minimum of age class? If I want to get the minimum of age, what do you think will be my function? Okay, we can use the minimum function. I'm not sure if we used this last time, but could you kindly get the minimum of age class and tell me if it will run or not? minimum of age, will it run or not? Did it run on your end?
No sir, because the age po is parang naka-contain siya sa loob ng data.
Yes, correct. Thank you. Thank you. That's very correct. Okay. Thank you. So you notice that there's no age object here. So R will not understand this. If I run minimum of age, there will be an error, object age not found. So how do I access age? I have to go to the data. The the object is data itself. I should have named it differently because data is generic, so it might confuse you with the data object and the data, which is a generic noun. Anyway, data and then dollar class. By typing dollar, you can access whatever's inside the data object. So arrow down, age. So that's what I want. And then tab, press tab. There you go. I don't have to type age. Control enter. So in this case, we have a minimum age of 18. And let's see maximum. Data once again, dollar. Okay. Down arrow, tab, control enter. So 70. Okay, so indeed, it worked. The Pmax and Pmin worked. It limited the minimum and the maximum. And then they are all non-decimal places. Okay. All right. Do we have the same age class in first observation, 37, and the same purchase amount 102.41? Kindly confirm, please. If we have the same values, 37, 102.41, good. Good. Food, credit card, and customer satisfaction 4. Okay, how is that possible? These are random numbers. It was made possible because of the set.c class. This one. So you'll have to run that at the beginning before you run your randomized functions, random functions. Okay. All right, that's good. So I gave you the notes there. You may just refer to that class. Okay. All right. So we have the data already. We can take a look at the data. The head function gives us the first 6 rows, and the tail function gives us the last 6. Okay. So head data. Control enter. So those are the first 6 observations. You can modify this if you want the first 10 observations. Just type the number. Head data 10. It will give us the first 10 numbers. Control enter. All right. There you go. Okay, tail, same thing. If you don't put any number there, it's the default 6. Control enter. So you can see here that this is the 495th up to the 500th observation. Okay, so that's our tail. Now, structure of the data gives us some information about the data. Okay, so take a look at this one. So this is a table. It's a special table. Okay, 500 by 6. 500 rows by 6 observations. And again, you find this dollar sign here. Dollar. Dollar customer ID. This is integer from 1 up to 100. Age is numeric. Again, 500 observations. Purchase amount is also numeric. Okay. And then product category, it's a factor. Okay. Now, what do you mean by factor? And that happens when you create okay, a factor class. Factor is a type of categorical variable or character variable that can be used for that can be used for classification. So for product category, you have electronics and you have the others, okay, the four other categories, and they can be used as classifier. Same thing with payment method. Actually, this can also be here. It's just a character. Okay, not all characters can be used as factors. For example, if you have a list, 1 million list of addresses. Okay, I'm not referring to just the city because the city can be a factor. But if you have the complete address and the street and the zip code and you have millions of data, imagine how can you classify that? How can you group them? Okay, especially if you have 1 million different individuals coming from different addresses, then it does not make any sense to use that as a factor. A factor is a type of categorical variable which can be used as a classifier. For example, country. So you have you have let's say part of Asia. You have ASEAN, North Asia, West Asia, Middle East, etc. If you have that variable, for example, you have Philippines, and then you have part of Asia, then Philippines will go to Southeast Asia or ASEAN. And then you have, for example, Japan. It will go to North Asia, okay, etc. So that type of a variable can be used as a factor, but it does not automatically it's not automatically loaded into R as a factor. In this case, class, in this case, payment method, okay, is a character, but that can be classified, that can be reclassified as a factor. We'll learn that when we go to regression. Credit card, cash, okay, and digital payment. Those are the levels there. Customer satisfaction, it's integer, okay, 1 up to 5. Okay, so that's what the STR data gives us. The summary data gives us the 6 number summaries of each of the data here. Okay, it will be meaningful only for numerical data because it will compute the mean, minimum, the maximum, the first quartile, second quartile, third quartile, and the average. So there's no average for categorical variables. Okay? How can you get the average of this when they are uh, when they are characters? Okay. All right. So let's run this summary. All right. Customer ID. Of course, customer ID, okay, can be converted into actually a character, into just a label because you don't really compute for the mean median mode of your customer ID. Age is okay, minimum is 18, maximum is 70. The average is 45.36. We wrote this, right? Mean is equal to 45, standard deviation is equal to 15. Okay, median is 45, first quartile, third quartile, median is second quartile. Okay, purchase amount, same thing. Product category, you notice that it does not give us the 6 number summary, but rather it gives us the levels and the frequency. Electronics has 170, apparel 119, home goods 109, beauty has only 18. Okay, here payment method also. Okay, take note of the difference. Here, this is just character, so it did not give the level. This one is a factor, so it automatically gave the level. So if I convert this into a factor, then it will also give me payment method is cash or credit card or digital payment. Okay, so customer satisfaction actually, okay, well, mean is 3.458, okay, which means on the average on the average Okay, the 1 and 5, the average should be 3. Because 1 and 5, that's 6. So above average yung customer satisfaction. All right. So let's now go to distribution of data. So let's first deal with categorical variables. So when you do your descriptive statistics, you of course differentiate between your you differentiate between your your categorical variables and let me see if I can just control out names of data. Okay, names of data. The names function will give us what's inside the object here, data. So these are the variables, okay? Just for me to be payment method, age, product category, six actually. All right. Now, if I want to get the frequency distribution, although this has already been given under summary here. So I know that there are 170 electronics, 18 beauty. I can also do that using the function table. Okay. So here, all right, wait. So okay, this one I did not give animal plus because anyway, I'll just to complete the notes here. So for those of you who were not able to have it, there. Okay. And then this one class. All right. So this one you can, okay, so we're now here, this part. Anyway, I'll just give this. This is the third part. We're looking at the distribution of the data. So when you take a look at the distribution of the data, it's good for you to distinguish between categorical and numeric. So how do we create frequency tables? Frequency tables are for categorical variables. Okay, you don't use it for numerical variables because numerical variables are continuous. So you cannot, for example, if you have sales with decimal places, you cannot group sales into, let's say, all the 130.10 sales, all the 130.11 sales. Yeah, you cannot do that. You don't do a frequency tables for numerical variables. All right. So I want you to write this on your own. Okay. I'm creating, I'll call it product frequency. Okay. So let's have a count of product frequency. Let's have a count of the products. Okay. The different types of products or the different levels. When you say levels, different classifications of your product. Okay. And the function that we can use is table. So here, again, we write data, and then we access what's inside data, dollar, and you have here product, product category. Okay. And then press tab. There you go. Now the table function class, so we're creating this object called product frequency, will give us a frequency distribution of the object of the variable product category, which is inside product. So if I highlight this and then run this, control enter. Okay, there you go. So that's from the table function. 170, 119, 109. Is it the same here? Okay, I don't have now the summary. But it should be the same class. Summary. Okay. 170, 119, 109. Okay. Exactly the same. All right. Then sometimes what you need, what you're interested in, maybe maybe not the frequency, but the proportion. So here we use the not the table function, but the proportion proportion table, proportion, okay, and we get the proportion of the frequency table, the product frequency. So you need to create this first, this object, and then get the proportion. So if I run this, let me run both. All right, there you go. So we have easily converted it into its percentage. So electronics dominate the sales of the company at 34%, apparel at 24, home goods at 21, etc. Okay. Beauty products bring up the rear at around 3.6%. Okay, I'll give you a few minutes, class, a few seconds to copy and please chat in the chat box once you're done. If you were able to follow, or in case you have any questions, please feel free to raise your hand. Okay, thank you for your feedback. Good. Okay, so you can see here, in order for you to create this proportion, you'll have to create first the frequency table. Okay, table first, and then proportion, prop that table next, so that you can create good. Thank you so much. All right. Okay, as we go along, class, I'll be we'll be discussing how we can create a neat table out of this. Because in your paper, for example, this will not be good unless you copy this and paste it into Excel, and then you have to edit that. R is very powerful in creating tables, tables that are better looking than, better in appearance than the tables in Excel. Okay, so we learned that. For now, let's just learn the table function and the prop.table function. Okay, so let me close this. Okay, now question. I have a question here. Okay, so let me, I'll put in the, so that everything is recorded. I think I better do that. Oops, what happened? So na-paragraph siya. Anyone who can tell me how to hide there? What happened here? Naka-paragraph siya, class. How do I remove that? View? Is it in the view? Show print? Is it the print layout? No. Okay, anyway, Control B. Okay, just deal with that later. So that's the code that we just did. I'm I'll do that every time, class, so that in case you lost your notes or you need to yeah, thank you, Hannah. In case you need to do that again, okay, it will always be available. All right, so let me go back to so my question, go back to my question. Do we always need to always go through the data in order to get, let's say like this, the frequency table? We have to use table and then data dollar product category. Or if we're getting for example, the standard deviation of a particular variable, and it's inside your data object. Do we need to go to the data? Is there a way for us not to go to the data, class? Any suggestion? I don't think I've discussed that. So, okay. So let's do this, class. Control Alt I. So create your, so I'll put here no, not necessarily. With the use, the detach, the data object. Okay, so I'm suggesting here that if you don't want to keep on using data, okay, there is a way to go about that. Okay, however, caveat, it's best used when you're only dealing with one data, okay, or when you have a certain process, and then for the next processes, you'll be using only that object, that data, then you can do this, okay? So what do? We detach. We detach our data, okay? So, and then if I run this class, Control Enter. Oh, why? Error. Okay, wait on. It's a of our data. Okay, let me just, that's impossible. Why am I getting an error turn here? I'm going to go to the help function and did it run in your case, class? And after that, let's get the standard deviation of, let's say, age. Okay, try that, class. Detach, yeah, it's in base R. Here. Oh no, subset. Here. This should work. Detach it from a search path. Okay. Let me run it here. Detach. Detach, then data. Oops. Detach and then data. Why? Okay, how about in your case, class? Invalid name. Okay, let me check the syntax. Did they change the syntax? So detach a database, remove it from the search path of. Usually this is either a data frame, okay, which has been attached, or a package which was attached by the library. Okay. Oh, this is the first time this happened to me. Why am I getting invalid? Does it have something to do with the table? Okay, let me just use data one. Let me just check this class. Okay, I have data one, and then I'm just checking this first, huh? And then structure, data one. Okay, and then detach data one. Doesn't. Okay, sorry about this class, but I don't want to spend too much time on this. I'll have to check class. I always use this. I always use it. My question is, why am I now, unless they changed, but I checked it, it's still working. Okay, attach and detach, detach. Okay, it should work, but it's not working. So I will have to put here a question mark. Okay, why, so that I can review this. Why is detach not working? Okay, all right. So what happens when you detach, class? When you detach, it means that I sorry, class. No. Okay, wait. I got confused. Yeah. So sorry, class. I was thinking of the reverse. Yeah, thank you, Hannah. Yeah. I got confused. I was thinking of removing, okay? Removing a package. So we can make use of the, okay, I stand corrected. It should be attach data, attach function. Okay, so when you attach function, class, it means that all the functions, all the objects that you're going to mention will be coming from this object data. So if I compute for the standard deviation of age, I need not, okay, so let me just compare this SD with data dollar age. So this one will still work, okay? But this one will be okay too. So if I run this, control enter, see you have two the same the same standard deviations. Okay, so you use attach. Okay, and then if there's a need for you, I was thinking of the last part. If there's a need for you to remove the attachment because you'll have already you're looking at several objects at the same time, then you can just detach it. Detach, and then data, detach, and then data, and then get, for example, SD of age. Okay, so let me run this first. Detach data, and then get the standard deviation of age. This will no longer work, okay, because R does not anymore recognize age, okay, because it's not here. However, if you have this, if you attached it, okay, it will recognize that this object age is coming from your this variable is coming from your data object. Okay, so pause for a while. May I have your feedback, please, if you're able to follow. Thank you, Hannah, for your comment. Thank you. Good. Thank you, Don. About the others? Plus, I seek your approval. We'll not have any breaks anymore, okay? So that we can finish at 9. Okay, we'll just try to finish as many as we can. Okay. Anyway, we started at 6:30. Okay, how about the others? Are you able to follow? Okay. All right. Thank you, Raf. Take your time, Raf. The codes, Raf, is in our, okay, in case you were not you were not here when I announced this. Okay, it's here in our Google Drive. Okay, and if you don't have the link to the Google Drive, I'll put it in the chat box again. Okay, and you can find it in January 31 text and codes. Okay, everything here is what we have discussed so far. Okay, so yeah, I guess I need to copy this side. Control C. Okay. Okay, so this one is supposed to be an exercise, but let's do it together, class. Payment method class is also categorical, right? It's also categorical. So let's copy this and just change it. Control C, because the codes are the same. Just copy it, class. Control V. And then we will have to change this into the payment method. So start with data and then dollar. Okay, payment method there. Let me call it not product but payment. Oops, double. I'll call it payment frequency, and then the proportionality payment, yeah, same name. Okay, so again, the concept is quite easy. You first create a frequency table using the table function, and then you have to identify, you give a name to the object. So we use table and then the object and then the specific variable inside it. Okay, and then we print this. Let's see. Oh, sorry. This should also be changed to payment. Okay. So what happened? What will happen, class, if I fail to change this? Okay. The product payment now will be the payment method. Okay. So that will be quite confusing. So if I run this, all right. So you have three levels: cash, credit card, and digital wallet. Okay. So 60% of the purchases were done by the customers through their credit card, and 26% cash, and then only percent digital wallet. Yeah, of course, this is just simulated data. Okay, once again, class, your feedback, please. Were you able to do that? And simultaneously, I want you to give your comment if my pace is okay. Okay, because I would want to seek your feedback. I might be going too fast. I'm aware that this is your first time to be using R. Okay, thank you. Okay, good. How about the others? Okay. I hope the others are able to follow. All right. Of course, class, if you want this to be in percent, you can just multiply this by 100. Sometimes you might want not the decimal, but I'll just run this again. So this is now in, oops. Wait, what happened? So yeah, this should be outside. Sorry, class. Okay, there. Okay. Let me Control C. Let me just put some notes here, again, for your reference. In decimal terms. This one. Okay. All right. So good. And then once again, as I said, for your review later on, I'll just make this complete. Okay. All right. Moving on, class. Okay. So it's not. So we're still with we're still with number letter A, right? Letter A. We're still with categorical variables. Distribution of data, categorical variables. And aside from frequency distribution, we can create plots. Okay, bar plots are simply vertical rectangles of the frequency of your data. So I'm going to use bar plot table. Then again, if I use attach data, I would not have no need to include this. Okay, once again, bar plot, and we'd like to create a bar plot of the frequency distribution, okay, of your object product category. Give it a name, product category distribution, and then give it any color you want. Okay, you can search in the internet the colors that can be adapted in plots in R. Okay, quite a lot. Okay, and you can name it in RGB color, there HUE color schemes. There are many different colors for you to choose from. So if I run this, we can, you see, class, that our data is arranged from biggest to lowest. And that was because of this. So just to this one, class. Factor in frequency. Okay. So this made it because the default will be alphabetical. Okay. So you would see apparel and then beauty. But here I want that our bar plots to be in descending order. Okay, so this is I'll copy this, Control C. This is now, okay, let me copy this one also because this is a lot longer. Control C. This is now ggplot2. And of course, we're not really going to, I'm not going to try to explain really the process. It will take long, okay? However, I want you to be familiar with the ggplot2 package because it's a very powerful package for data visualization. Okay, for me, nothing beats ggplot2. Okay, so this might be quite tough to follow. Okay, but the objective again is mostly for you to see the power of some packages in R, in this case, ggplot2. So what's happening here is we first, from the data, all right, this is the old, if you recall, this is the old pipe operator. I'll replace it with Control Shift M. Okay, this is the new one. And in Mac, it's Control, uh, what's that class? Option M, I think. In Windows, it's Control Shift M. Okay, so what happens here is that we first count the product category and we create this percentage of the product category. And then here we're creating the plot. Okay. And if you're new with ggplot2, the learning curve could be quite stiff. But there are many basic functions of ggplot2. So this is a bit intermediate. Okay. But the objective here is let's just run this and see the difference. Okay, run the code chunk. And then you can see that here we were able to put the percentages above. And it's better looking, better for, okay, you can also change the color. This is dark red of the percentages. Okay. All right. So quick review for categorical data. When we take a look at the distribution, we go to the frequency table, either in terms of the discrete count or the proportion. You can do that. And also you can create bar plots, either the basic bar plot or the more complicated, but the better looking ggplot2. Anyway, they're the same. So this will do. Okay? And it's a lot simple. But actually, we can modify this to also include the, it will just, I will have to review class the how to append the percentage here, just like here in ggplot2. But it can be done also. All right, so aside from that, let's now get the bar plot, this time for the payment method. Okay, so let me share this with you. Same thing with the bar plot and the ggplot. Okay. I'll give you time to copy. And this one is just like the same above. This time, we're plotting the payment method. Payment method, and then give it a certain color, salmon. Okay, there you go. So in this case, you notice that we did not do this. Okay, we did not do this function for payment method. Okay, you can actually also do this, okay, for payment method, because you have your payment method here, and then you can also order the factor by frequency. Okay, I leave that to you as an exercise. Just put a comma there and copy the rest. Okay, so you notice that this is arranged alphabetically. Okay, it would be good for it to be arranged in descending order, highest to lowest. Okay, so and this is the same thing. This is the Google gplot method. Okay, same plot. Okay, but the plot is a lot nicer. Okay, and it automatically, class, take a look. it automatically arrange your data. Okay, and not really automatically because we had some, there's a portion here of that code which arranges it. Okay. No. Here. Sort. We sorted it class. Arrange descending order. Okay. We arrange it in descending order. That's why you have this plot. All right. Pause for a while, class. So far, we have discussed categorical variables. Okay, so we can create, so let's say you have your data, you're doing some analysis. It's always important as part of your research, as part of your discussion, descriptive statistics. Okay, if you have categories in your data, it's important to show a frequency table and also a plot. Okay, so again, in your cases, especially in your final paper, I expect you to include descriptive statistics. Then we go to the next part of our distribution of our data. So we're here just to situate ourselves. We're in distribution of data. First, we looked at categorical. Then let's take a look at numeric here, numerical variables. One of the easiest way to show the distribution of your numerical variable is your histogram. Okay, so what's a histogram? So let's use purchase amount. Okay, so you have age, you have purchase amount. These are your, once again, let me use names. Okay, and then data. Oops, sorry, I should have placed it inside. Code Control Alt I. Names data, just for me to be reminded. Okay, so our numeric variables are age, okay, and then purchase amount, customer satisfaction 1 to 5. Well, it can be treated as both numeric, okay, or it can be categorical because we can also count how many how many people answered 1, how many people were very satisfied, how many were not satisfied. In that regard, then you should include that in your categorical variable account of your accounting frequency table of your customer satisfaction. Okay, I leave that to you as an exercise class. So for now, let's go to our numerical variables. Here we're going to create a histogram, and the function is just this is from base R. So we have your data, purchase amount, and then the main plot has this name and X label. This should be in PHP, Philippine pesos. Okay, and then let's give it a color of light green. Notice that when you give a color of light green, R automatically gives the shade. So you know, for example, I make this blue. Blue, okay? You notice that it automatically gives the shade. Control Z. Okay, so let's run this. Okay, so here you see class, the histogram. It divides it into 3, 4, 5, 6, 7, 8. Here it divides it into 8 bins, and you can see that our data, okay, it's skewed to the right. There are many, not many. The propensity, the concentration of your data is in the small amount, okay? Small amount, 0 to 1,000. Okay, those are the purchases that really dominate. And then there are very few that have 8,000, okay, from the range of 7,000 to 8,000, etc. Okay. So we can also create okay, a box plot. Okay, so let's create a box plot for purchase amount. Let's run this. And this is your box plot. If you recall from your stat, okay, so this is your this is your first quartile, okay, this is your second quartile, this is your average, okay, this is your IQR, okay, third quartile, and then this is quartile 3 plus your IQR, okay, and then minus your IQR. These are your whiskers, and these are values that are outliers. Okay, so we have many outliers for our purchase amounts. Okay, using the box plot. Okay, so let me share. And then there's another one, density plot. Okay, so let me, okay, I'll just share everything first, and then let's go through it one by one. So here for numerical variables, Control C. Okay. All right. So we can use the histogram. Okay. We can use the box plot. We can use also the density plot. So there are different ways to represent your numerical variables. Histograms are the most simple ones. Okay. Box plots, you can generate more information out of box plots compared to histograms. Okay. So in fact, it's quite difficult to see if there are, you will not be able to see really the magnitude of the outliers. We can consider these outliers because they're really very far from the mean. Okay, the mean should most likely be here. Okay, and then this is your box plot. Here you can see also here are the outliers. These ones. Okay, I hope I am not going to go into the details of this because I assume that you have had statistics subjects before. Okay, at least basic statistics. And then another way to present it is your density plot. Okay, so use plot and then density. Here, you have box plot. Here, plot density and then your object. On the other hand, here, it's simply hist. Okay, so three different ways to present your data. Density plot. Okay, it's similar, of course, to your box plot. Sorry, to your histogram, only that this is smoothened. Okay, unlike the histogram, which are boxes. All right, now I shared with you this one. We can overlay your density plot and your, okay, sorry. So let me see. What did I do here? Okay, apologies. Okay, the purchase amount should be below class. And wait. Did I repeat this? Okay, wait. Let's run this first. So you have your base R. Okay. All right. So this is the layering. Okay. We first plot the density, and then here we're plotting the. Okay. Here we are plotting the density field. So this is also density. So let's plot this together. Okay. So this is sorry, this is the density plot class, this one. So let me put here some comments. Density plot using ggplot. Here the density plot is using base R. This is the density plot using ggplot2, and you can see the difference, class. So this is your basic density plot using base, and then this is your R class. And you can see here the this one pertains to the count. So many. This blackened one means there are many counts of your data that are concentrated here, and just a few here in the upper upper purchase amounts. Okay, and the last one is a layering. Okay, here I said layer your histogram with your density plot. If I layer this, okay, you can see now a combination of your density plot and your histogram. So this is for your purchase amount. All right. Okay, so take note that when you present your categorical data, there will be different ways to present it, like frequency table, or what we did a while ago. Okay. We had our bar plot, okay, for our categorical data. For numerical, we have you can use histogram, you can use box plot, you can use density plots, you can use the layered, okay? You layered histogram and density plot. Of course, class, the ggplot will always be better than your base plot. What's good is that you can refer to several references. There are many videos on ggplot2 and many sites. Okay, and of course the presence now of AI. Okay, Chat GPT, Claude, you can ask on how to code a particular plot, for example. Okay, then uh, aside from, okay, so let's just situate ourselves. We are now in okay, 3. A is categorical, B is quantitative, and C is taking a look at your normality, the normality of your data here, normality check. Now, we will reserve the the discussion of the importance of a data being normally distributed later on, and later on, not today, but it's very important to check if your data is normally distributed, because the methodology could also be dictated by the distribution of the data. So there's a test called Shapiro-Wilk test. Okay, and we can use that Shapiro.test. Okay, let me once again share this, and I'll include this. Okay, maybe the last one. There's still so many here. Okay. Include this Control C. Include everything, class. So that even if we don't get to finish it, okay, you have the notes. Okay, so let's see how far we can get. Most probably we will not be able to finish everything here. Okay, because this is quite a long discussion. All right, normality class. So how do you know if a numerical variable is normally distributed? Okay, you don't check normality for categorical variables. So here we're checking purchase amount. Okay, maybe we can include also. Let's check also. Let's copy this too. Control C. Test of normality. I should have included this. Normality for what's the other variable? I keep on forgetting. Data here. Purchase amount and wait, age. Ano? Wait. Why is there only one here? What was the other categorical numerical variable that we, aside from age? Yeah, it's only purchase amount. I'm sorry. I got confused. Purchase amount, payment method, and product categories are not quantitative. Okay, apologies for that. So let me delete this one. Okay, we only have actually age. Okay, for just for the purposes of discussion, let's see if the age is normally distributed. Here we expect it to be normally distributed. In fact, we used R norm. Okay, so just for the purposes of discussion class, we will include age here. And then so let's replace this. The quantile plot, age, and then age. So I hope you're following along. Age. Okay, so let's first do the more pertinent one, the purchase amount. So if we run this class, so this is our first statistical test, Shapiro.test. We're going to meet this again when we go to regression. Control, run this. All right. So in a statistical test, it's important to identify what your null hypothesis is. So in this case, our null hypothesis is the data is normally, the data in particular, the data purchase amount is normally distributed. So that's our test class. That's what we're hypothesizing. Our data is normally distributed. So when we run Shapiro.test, data purchase amount, you notice that we have our Shapiro statistic 0.513, and then the p-value is practically 0, 2.2 e to the negative 16. So this means from your 2, you go to the left 16 times. So that will be point and then 15 zeros and then 2. So that's practically 0 class. Now, the null hypothesis is, okay, the data is normally distributed. The rule is when your p is less than 0.05, then you reject the null hypothesis. Okay, so our p is much, much lower than 0.05. Therefore, we're rejecting the null hypothesis that our purchase amount is normally distributed. In fact, I told you that I tweaked it in such a way that we will have outliers, many outliers. Okay, so you can use also, this is called your quantile plot, QQ plot. quantile plot. Okay, and the function is QQ norm and QQ line. So if I run this class, you can see that, okay, this is your QQ line. If the data is normally distributed, the dots should concentrate around the red line. But notice that at higher values, your data is way outside of your quantile line. So this tells us that you have problems with your higher data. Okay, so this tells us that using the QQ plot and the QQ line, you can see that your data is not normally distributed. Now compare that with your age. So again, here let's test. I suspect that this is normally distributed. All right. Still not. Okay. So it's based on Shapiro-Wilk, it's still not normally distributed. Okay, this is also practically zero. It's less than 0.05. So since the null hypothesis is that the age data is normally distributed, then we still, wait, sorry. Non-normal, okay. Yeah, non-normal, okay. So we reject, sorry, yeah, we're correct. We reject the null hypothesis that the data is normally distributed. We reject that. We have reason to believe that our data is is not normally distributed. Okay, so we also use the QQ plot, but this will be a bit closer as compared to the purchase amount there. Take a look at this. Okay, so mostly all on the QQ line. Okay, unlike the other one where it really deviates from the QQ line. For this one, only in the higher values here and the lower values here. Okay, so we'll reserve more discussion of this, especially when we go to multiple linear regression. Okay, and these ones are quite easy. Okay, measures of central tendency, okay, measures of variability. These are very important, especially when you're looking at, of course, quantitative variables, especially when you do multiple linear regression, and then your variable of interest, you should be really studying your dependent variable. Okay, so what are we doing here? We're creating this object called mean of purchase. So this is just the mean of your purchase amount and the median of your purchase amount, mean and median. If you run this, notice class that I put here a parenthesis. Okay, I don't think I've shared this. Okay, let me share this. Oh yeah, I shared everything already, sorry. Yeah, I forgot. So notice that here I included the parenthesis here. Okay, let me include the parenthesis for the mean, but not for the median. If you want to automatically print mean purchase, okay, you put the code in open and close parentheses. In this case, in median, on the other hand, we didn't put it. So if you run this, it will only print the mean purchase, okay, but not the median. Okay, but the mean and the median are here. Mean 545, median 247. So let me put the parentheses here and rerun this here. So you have here now 545 and 247. So this tells us, class, that the data is, if you recall from your stat class, so here you have your, say this is your mean, and this is your median. Okay. If your mean is to the right of your median, then this means that more concentration of the data is on the right side. So we say that this is skewed to the right. On the other hand, if the mean is to the left of the median, then it will be skewed to the left. So follow the mean, okay? Follow the mean. Take a look at where its position is. So this is the median. This is the mean, okay? The mean is way, way to the right of the median. So this tells us that indeed there are many data that are really very, very high in value. Okay, so aside from that, okay, still have a few more minutes. Now, of course, this one class, this is coding in R. We will not learn this, but I just want to share this with you to create, okay, the mode, okay, get mode. So you have here a function, and it's to tabulate, okay. The mode class is supposed to give a count of, okay, so when you say mode class, what is the biggest number? Okay, what's the biggest number? And the mode class is will only be let's say relevant for a categorical variable. So for example, well, a categorical that is expressed as a number. For example, here, payment method. Okay. Okay, let me rephrase that class. So the mean and the median are good for quantitative variables. And then the mode is for categorical because this is counting. So if you run this class, it tells us, okay, okay, take note of this. Mean purchase, it's this one, okay, with the colon here, and then the n. It gives a count, okay? The mean purchase. The mean purchase is the mean purchase is, okay, we have that already, right? We computed that. Okay, mean purchase and median purchase. We computed that already. We have that those objects, so this is recognized. Okay, so it appends median purchase. Okay, see how the text is printed, median purchase, colon, and then the amount of your median purchase, this one. And then mode payment method, credit card. Okay, which means this is unimodal, which means there's only one mode. Okay, the mode is the number that has the highest frequency. Okay, so okay, we can just okay, let me see. The next one is quite long. Okay, so maybe we'll just have a start of this. Okay, these are just some guidelines on how you should create your descriptive statistics. Okay, so here, class, variability. Okay, this is quite easy. The range, the standard deviation, the variance, the interquartile range, the mean absolute deviation, and then here it prints the range, the standard deviation, and the IQR. Okay, so this is quite simple. You're just creating this object range purchase. So this is the function range of data purchase amount. So we're looking again at purchase amount and compute for the range. The range is simply the difference between your highest value and your lowest value. And then you know the standard deviation, the variance. IQR is simply quartile 3 minus quartile 1. And mean absolute deviation, there's a formula for that, okay, which we'll not discuss. Okay, and then it will print the range, the standard deviation, and the IQR. Okay. If you run this class, notice it prints the range. Okay. The standard deviation and the IQR. Okay, the range class is two values, the lowest and the highest. So you have a purchase of 7.68 pesos and the purchase maximum is 7,656. So this is the amount that was highest value purchased, and this one just 7.68 pesos. Okay. Right, you can of course include here also the MAD, the mean absolute deviation, which is equal to, you should have it now here in your okay, MAD purchase 219, mean absolute deviation. Okay, so okay, I'm really thinking about okay, so just the note so that next meeting we'll just continue with what we have left off. There are some commands here. Okay, I want us to really actually that's all. So maybe as part of your quote unquote assignment, I will request you to run this on your own, and then so that next meeting we'll just we will be okay, we'll be able to just discuss it. Okay, so here are some notes, class, about data summarization tools. Okay, summarizing data is part of descriptive statistics. So this is just a review for, of course, you have to provide a count. Okay, and some functions like summary will do that for us. And it's important for you to, of course, the names of your variables, okay, the types, whether they're categorical or factors, etc. Provide information on as many types of fields as possible, okay, numeric, categorical, character, factor, and then produce appropriate summary stats depending on the data type. As we have learned, we don't have the 5-number summary for categorical data. Okay, you don't get mean, median, mode. Don't get quartile one, etc. You do that for quantitative variable. Okay, so for example, a mean of a categorical field does not make any sense. Okay, now, so far we have not discussed this dealing with missing data. We'll discuss this later on when we go to our inferential statistics. So what do you do when you have your data? And usually you may, if it's not primary data, even primary data, primary data is data that you produce yourself by asking people to answer surveys, for example, and you collect the data. That's primary data. Secondary data is data that you just get from the outside, okay, which you did not do on your own. Okay, for numeric data, we said that there are some metrics, mean, median, range. Okay, of course, for measures of central tendency, measures of variability, those are very important, like some measure of variability, okay, even key percentiles, 10th quartile, first quartile, etc. And skew and kurtosis also. So that's important to also include. For categorical, as we have mentioned, count, okay, and of course, frequency table, okay, and then maybe a count of the most, the highest among the categories, just like what we did in the proportion. So the proportion will answer that. Okay. And then sometimes we haven't done this. Okay. We it's good also to summarize by group. Okay, when you say by group, for example, you have a category male and female, gender, for example. So you can summarize the data by male and by female. So you'll split the data. For example, age. What is the average age for male? What is the average age for female? For example, you have salary. What is the average salary for male and female? You can do that. Okay, you can summarize by group. We'll have examples of that. Okay, external library. Okay. Okay, this is about packages. Okay, and this one, lastly, class, this one, cable. We're going to discuss this because so far, what we have generated are, for example, the frequency table. They're not good when you they're not really APA format when you put that in a research paper. So what we're going to learn is how to summarize your data in a tidy format so that it's acceptable as an APA format. So we're going to use the cable package in the future. So these are some of the functions that can be used for descriptive statistics. We know this, some summary data. Okay, and similar to this, that is the glimpse. Okay, let's just run both. Okay, you can see that. Oh, sorry. Oh, my bad, class. Glimpse, okay. Glimpse is not from Tidyverse. Very bad. So let me, I think it's from Sitebar. Anyway, okay, there. No, sorry. It's not summary. My apologies, class. So please change it to structure. Okay, and you can see that structure is almost the same as your glimpse. Okay, only this one, the font of the data type is better printed. Okay, so it's practically the same plus. And then this is an example. Okay, you should buy data and your data product and then summary. We want to summarize this for each of the product category. Let's see what happens here. Okay, so first electronics. Okay, so this has no consequence. Age, okay, the mean for the age for those electronics, those buying electronics, take note of this. Okay, you can see that for apparel, the average is different, 45.98. For electronics, it's 44.84. So what happened here? Okay, so it split electronics, all the data containing electronics, and then it got the summary for the age, for the purchase amount. Okay, so those are the two most relevant ones. And then payment method, how many bought electronics? 170. Okay, so it's doing the summary function for each of the categories here. So this is how you do it by data and data product and then summary. Okay, so if you want to present your data in this way, okay, each of the categories of your product will have its own summary statistics. And then we have this. Okay, you can use the HMISC. I think we ran this before. Okay. Oops. Gives us also some. Okay. So it gives us the 6 variables: customer ID, the age, purchase amount, and it gives us some summary statistics. number, the missing values, none, okay, the average, etc. So these are all summary statistics. And then we have paste text. Okay, paste text for the stat.describe. Okay, this one shows the summary statistics in your rows, range, sum, mean, median. Okay, however, it includes those that are not really relevant. Okay, you don't really get the maximum of your customer ID, purchase amount, and for your categorical, it's NA here, which is correct. Okay, customer satisfaction, if this was classified as a factor, then it will not also compute the summary statistics for this. Okay, just I think two more. Okay. Let me, so HMIS, base text, site data set also. If we run this, okay, almost the same thing. These are your variables. Okay, again, the weakness of this is that the categorical variables, although it placed it as a asterisk, it's still computed for the mean or standard deviation, which makes no sense. So these are the weaknesses of this descriptive statistic functions. Okay, and then this one, which is also interesting, described by data, and then a product category. All right, if you take a look at this, okay, there are several windows here. So it's just the same as above. Electronics group, it's now grouping it into, okay, it's grouped into, we can see the different product categories. Okay, so it computed for the age, the mean, standard deviation. These are the beauty products, 18 lang kasi siya. No? Okay, you can also do that by classification, by group, using the site package. And then skim R, okay, what's good about this is that you have a histogram at the end. And also it does not include the categorical variables. Okay, except for okay, wait. 1, 2, 3, 4, 5. Oh, sorry. Yeah, it did include it, sorry. Okay. 1 character, 1 factor, and 4 numeric. This page. Okay, so it classified the different types of variables. Okay. And then lastly, this one, using summary tools, you have the DES describe data. All right. For me, I don't like the way this is presented. Okay. So it takes a look at the metrics, and then on your columns are your variables. And you notice there are only the quote unquote quantitative. Okay. What we could have done here should be to, so if you're only going to do that for the age and purchase amount, you could have created another object, including only age and purchase amount, and do the summary. Okay. Do the summary tools. All right, so we end here, class. And of course, when you do your write-up, you have to do your key findings. This is just an example. Purchase amount is right skewed. The mean is greater than the median, with outliers on the other hand. The most popular product is, so there's a mistake here a while ago. It should be, okay, we have to check what of the product categories had the most frequency. Okay, payment method, the credit card is most common. There's also high standard deviation or high variability in your purchase amounts, etc. So these are just examples of key findings. So this is also important for your paper. You don't just put the tables, put the plots. You have to discuss and come up with a summary or key findings. Okay, so I guess just to let me just share this, Control C. Now, we will not discuss this, but if you're interested, and there are many tutorials about this, there's this function. It was developed by a French, okay, Esquizzer. Okay, let me run this, and it will generate a ggplot builder. So it makes running a ggplot a lot easier because it's just like a point and click. So if you're interested, okay, you can try to learn this. It makes ggplot2 a lot easier by building this one. Okay, so here are our data: customer ID, age, purchase. Okay, so this makes learning ggplot2 a lot easier. All right, so with that, class, okay, let me stop recording now.